Hello folks. I've heard from some of y'all that the last lesson we did was kind of difficult, so I'm going to run through a couple of practice problems for you in case you want to look at some extra work. We're going to get started with a couple of graphing questions. It's going to ask us to find the vertex axis of symmetry, all of that information as well. Starting with problem 1, we have y is equal to x minus 2 squared plus 3. We know that in vertex form, we get y is equal to a times x minus h squared plus k. And we know our vertex is the point h, comma, k. So in this case, our vertex looks like it's going to be 2, comma, 3. Let's go ahead and put that onto our graphs. We have a point at 2, comma, 3. What's our axis of symmetry? Well, it's the line running through this x point. So it's the line x is equal to 2. Do we expect this to be a minimum or a maximum? Well, our a value is positive. It's 1, so we expect this to open up. If our graph were to look something like this, our vertex would be the minimum. Vertex is the minimum. And what will our domain and range be? For a quadratic, our domain is always going to be all real numbers, so minus infinity to positive infinity. And our range, we said this value is our minimum. So 3 is our minimum here. And we're going to go all the way up to positive infinity. How are we going to do that? Well, we had that table of x and y values, where 1 squared is 1, 2 squared is 4, and 3 squared is 9, and so on. That's what we're going to do. From the vertex, we're going to go over 1, up 1, to either side. And then again, from the vertex, we're going to go over 2, up 4, 3, 4, over 2, up 4. And we would keep doing this if we went out to 3 and 9. From here, what we're going to do is we're going to sketch our graph. And voila, we're good to go. All right, let's do one more here. Y is equal to minus x plus 2 minus 1. Again, this should take the form y is equal to a times x minus h squared plus k. So what's h in this case? Looks to be minus 2 because we're adding. We've flipped this sign. And k looks to be minus 1. So our vertex for this will be minus 2, minus 1. Our axis of symmetry will be x is equal to minus 2. So let's go to minus 2, minus 1. Let's put our point down. We can dash out that this is our axis of symmetry as well. Now, is this going to be a maximum or a minimum? Well, our a value is minus 1, meaning that when we do this, we're going to go down, or that this value is a maximum. Our domain, like always, is minus infinity to positive infinity. And our range is going to be, well, this is our maximum value here. So we're going to start at minus infinity, and we're going to go to our maximum value of minus 1. Remember, for our range, we're looking for the y values. So our maximum is going to be our y value here. Again, to graph this, we're going to look at our table. This time we're going to multiply all our y values by a. So we're going to multiply all of them by minus 1, meaning that instead of going over 1 and up 1, like we usually would, we're going to go over 1 and down 1. So we're going to go over 1, down 1, over 1, down 1. We're going to go over 2, down 4, over 2, down 1, 2, 3, 4 from our vertex. We're going to go over 3 from our vertex and down 9. So we go over 1, 2, 3, we go down 9. And we can do that going the other way, or we can just flip this across our axis of symmetry. So we were 3 away from the axis on this side. We'll have another point that's 1, 2, 3 away. And from there, we're going to graph this. And that's a rough sketch of this graph. Let's move on. Now we're going to write a quadratic function to model a graph. What do we need to model a graph? Well, in vertex form, it's y is equal to a times x minus h squared plus k. So we're going to need to know h and k, which comes from our vertex, and we're going to need a second point to solve for a. Let's find our vertex. Looks like it's right here at the point 2, 3. Which means that our equation is y is equal to a times x minus 2 squared plus 3. What do we do from here? We need a second point to solve for a. So let's find another point. This one over here looks fine. That is the point 3, 4. So we're going to substitute in 3 for x and 4 for y. We get 4 is equal to a times 3 minus 2 squared plus 3. We subtract the 3, we get 1 is equal to a times 1 squared, or a is equal to 1. So now we have a, we have h, and we have k, meaning we can just substitute each of those values in to get our equation is y is equal to 1 times x minus 2 plus 3. X minus 2 squared. Let's do the second one as well. From here, we're going to go find our vertex. That vertex is at the point minus 3, minus 1. So our equation looks like y is equal to a times x minus a negative 3, or that's plus 3 squared minus 1. So let's rewrite that. That's y is equal to a times x plus 3 squared minus 1. And now we need a second point, like this point at minus 2, positive 1, which we're going to substitute in for x and y. So we get 1 is equal to a times minus 2 plus 3 squared minus 1. Let's add that 1 to the other side. We get 2 is equal to a times 1 squared. 1 squared is just 1, so this tells us a is equal to 2. And now we have a, we have h, and we have k, meaning that we can write our equation as y is equal to 2 times x plus 3 squared minus 1. These next two questions are more or less the same. We're writing the equation of each parabola in vertex form, except for this time we're given the 2 points. So we're just going to follow the same steps as above here, where we'll substitute in the vertex. This becomes y is equal to a times x minus 3 squared minus 2. And now we're going to substitute in the point 2, 3. So this becomes 3 is equal to a times 2 minus 3 squared minus 2. Move the 2 over, we get 5 is equal to a times 2 minus 3 is minus 1 squared. And minus 1 times minus 1 is positive 1. So this tells us a is equal to 5. Meaning that our equation will be y is equal to 5 times x minus 3 squared minus 2. What about identifying the vertex and axis of symmetry for each parabola, then graphing and writing a function in vertex form? We know that our axis of symmetry is the line x is equal to minus b over 2a. So let's go ahead and get started using that on problem 8 here. X will be equal to minus b, b being 2, so this is minus 2 over 2 times a is 1, so 1. Or this tells us our axis of symmetry is at minus 1. Let's go ahead and put that on our graph. 2, 3. Right. What do we do with this value? Well, that's the x value for our vertex. We need to find the y value, which we're going to do by substituting minus 1 in for x. We'd get y is equal to minus 1 squared plus 2 times minus 1 minus 5. or this is 1 minus 2 minus 5. That gives us negative 6. So our axis of symmetry is x is equal to minus 1. Our vertex is minus 1 minus 6. Let's go ahead and plot that on our line. We get minus 1 minus 6. And now we can use C, because C is our y-intercept, to find a point and mirror it. So we go up to our y-intercept of minus 5. And then we also mirror it across the axis of symmetry. So we were 1 away. We're going to be 1 away on the other side. And we can graph our parabola from there. Now it's asking us for the last thing to write the function in vertex form, meaning that we have to write this in y is equal to a times x minus h plus k. We have h and k, and our a value stays the same. Our a is still just positive 1, meaning that if we want to write this in vertex form, this becomes y is equal to 1 times x minus negative 1 squared minus 6. Okay, what about sketching a parabola using this information? Well, for this one, we have a vertex of 4 comma minus 2. So let's go to 4, 1, 2, 3, 4, minus 2. That is our vertex, meaning our axis of symmetry also runs through this area. We also know that our y-intercept is 6, so we can plot that onto our graph on 6. And we have an axis of symmetry, meaning we can flip this across the axis. This point was 1, 2, 3, 4 away. So we're going to go 1, 2, 3, 4 away and make a mirror point. And then from there, all we got to do is sketch our parabola. Let's do that once more because it was so much fun. Our vertex is at minus 3, positive 2. And we have a point at minus 1, 0. Now let's draw our axis of symmetry. And we're going to flip this point across our axis of symmetry. It was 2 away, so we're going to go 2 away on the other side. And then we're going to complete our graph. And there you have it. Here's a couple of practice problems that I've done. Feel free to watch this, try to keep an eye out, and try to figure out what is happening.